Welcome. In this episode, we're going to talk about solving a quadratic equation by the quadratic formula. Many of you probably know this formula, and if you don't, and this is a good time to review. So first of all, we start from the meaning of quadratic function. So first of all, what is a quadratic function? Quadratic equation. The general form of quadratic equation is ax squared plus bx plus c equals 0, provided that a is not 0. A, b, c are parameters. And the meaning is that as a function, the output is 0. The output is 0. So the statement will be saying that if this function produces an output equals 0, find all possible values, right? All possible x values. Okay, so that's the grammar in this situation. So if the output is 0 by this rule of the function, and our task is to identify all the inputs x such that the function is 0. If the function gave us a 0 output. Okay, quadratic formula is the following. Okay, so here we have x. I'm going to make the font just a little bit larger so we can see the signs well. So x is equals to, the denominator is 2a, and negative b plus or minus b squared minus 4ac. That's the quadratic formula, because a is not 0, so we don't have to worry about 0 denominator. So there's and this formula is very versatile because it will give you a solution to any quadratic equations. So here, let's look at some examples. Okay, in the example of x squared plus 5x plus 6 equals 0, right? And we can use the quadratic formula to find the equations, right? And here we're going to have the equations. We're going to have the quadratic equation, which is x squared, a is 1, b is 5, c is 6, right? So you can just use the solution straightforward, and x will equals to, we'll bring the formula with us. Okay, so 2 times 1, and negative 5, b is 5, and 5 squared minus 4 times a is 1, c is 6. And then we will get on the next line, and we just simplify. 2 times 1 is 2. Negative 5 plus minus, here's 25. 25 minus 24. 25 minus 24, that's equals to 1. Okay, so one more step. And now we're going to have 2 in the denominator and negative 5 plus or minus square root of 1. Square root of 1 is 1, right? And at this point, we will get the solution. And 1 is for minus, 1 is for plus. So we have 2 solutions, and we're going to use subscripts. X sub 1, that's going to be 2. So negative 5 minus 1, and this is going to give us negative 3. And the other one, we'll call it x sub 2, and that's going to be negative 5 plus 1 plus 1 divided by 2, which is going to give us negative 2. So we get the 2 solutions, and of course you probably saw this solution to this equation we had. We used this example in the last episode. So substituting the equation. Now, what if you have an equation that is not like it? It's not ax squared plus bx plus c equal to 0. What if it's not equal to 0? Well, then you're going to make it equal to 0. Okay. For example, we solved this equation using another way before, and this time you can just use our we transform it. So we make a 0 on the other side by subtracting 4 on both sides. So here we subtract 4 on both sides. Okay, and after we do that, and we ended up with a equals to 1, b equals to -3, c equals to -4. Okay, and then we plug in the formula. Okay, so 2 times 1, and negative of -3, negative of -3, plus or minus, and then this is taken square root, and b squared is -3 squared. Sorry, squared minus 4 times a is 1, c is -4. Okay, and then we're going to proceed with simplify this expression. Okay, so 4 times 1 is 2. Negative of -3 is +3. Plus minus over here, that's a 9. 9 minus 4 times -4. So that turned into a +16. And the next step, we will simplify the square root inside. So that's a 25. The square root of 25 is going to be 5. So this is going to be 5. Okay, so in the end, we're going to get 2 solutions. Equals to, one is 3 minus 5 divided by 2. That's going to give us a -1. And the other one is x sub 2 equals to 3 plus 5 divided by 2 equals to 4. So the solution to that equation is also going to be, and in terms of showing work, and that's what you can do. This is how you show your work. Okay, you just make a 0. You don't have to tell the reader you're making 0. You don't have to mention these words. So these words are purely optional. And subtracting 4 on both sides is optional. So when you show your work, you mainly just, you make it to the standard form, which is required, which is how the quadratic formula is derived, right? So make it 0, and then you plug in the numbers. Now the question is, do we always get such nice and neat numbers? Of course not. Okay, in fact, I'm going to talk about the 3 cases that the solutions that you may get for a quadratic equation. So we've done 2 examples. So let's look at the 3 cases. The 3 cases of solution to a quadratic equation. Okay, and these 3 cases are determined by something in the square root, which is, I'm going to bring this formula over here. Okay, because you see we have b squared minus 4ac, right? When we take a square root of a number, sometimes we may have b squared minus 4ac is positive, right? So we have 3 cases according to the sign of b squared minus 4ac. So these 3 cases are, okay, so these 3 cases are, I'm going to list the 3 cases. 2 rows. Okay, so the 3 cases is marked by b squared minus 4ac. One is greater than 0. One is equal to 0. And the other case is less than 0. What will happen if we have these cases? Okay, and so we're going to discuss these 3 cases. Okay, example number 1 and 2 fits the first case. Okay, if we go back to the equations of example number 1 and number 2, you'll notice that in example number 1, you can see that b squared minus 4ac, we have a 1 here. So that's a positive number. 1 is a positive. In case number 2, we have square root of 25. So 25 is the value for b squared minus 4ac. So the first case is covered by example number 1 and example number 2. So example number 3, we wish to show you the case that we may have something different, right? So for example, I may have x squared plus 4x plus 4 equals to 0. If I use the quadratic formula, I'm going to get, first I look at the p squared minus 4ac. Okay, b squared minus 4ac. This quantity is also called a discriminant, right? Discriminant. And first case, I'm sorry, b squared minus 4ac. In this particular case, our a is equals to 1, b is 4, c is 4. So when we assess b squared minus 4ac, so we have 4 squared minus 4 times 1 times 4. And we ended up with a 0. Okay, and in the quadratic formula, what happens? If b squared minus 4ac is 0, well, b is 4 here, a is 1, and this piece is 0, right, in this case. So we end up with what? We end up with 2 in the denominator, and negative 4 plus minus 0 is just, we have negative 4 left. So finally, we have negative 4. We don't have 2 different number solution. We actually have just 1 solutions, right? To summarize, in the case of b squared minus 4ac greater than 0, we have 2 solutions. In this case, when b squared minus 4ac, we have 1 real number solutions. And in the second case, when b squared minus 4ac is 0, we have 1 real number solution. In the first case, we have 2 real number solutions like we saw in example 1 and 2. Now, let's look at the case 1, example number 4. Okay, so here I'm going to have an example. I'm going to give you an example. Minus 2x plus 5 equals to 0. Okay, in this case, of course, we have a equals to 1, b equals to 2, c equals to 5. And b squared minus 4ac will give us 2 squared minus 4 times 1 times 5. And in this case, of course, we're going to have a 4 minus 20. This is obviously going to be a negative number. Here we have a negative 16. It's a negative number. Right? Let's check the answer. 2 squared minus 4ac, we have a negative 16. So this equation, well, if this is true, the solution, what will be the solution? The solution would be x equals to 2a, so 2 times 1 minus b minus 2 plus minus, okay, we have the square root. The square underneath the square root, we have b squared minus 4ac. We got it as negative 16. We get a square root of a negative 16. We know this is going to get us a complex number, right? So let's continue this process. Okay, so we have a 2 here, we have a negative 2 here, plus minus, and over here we're going to write it as the square root of negative 1 multiply the square root of 16. Okay, should tidy it up a little bit. Okay, and at this point, assuming you guys know about complex numbers, this is going to be I. Okay, and the square root of 16 is 4. So this piece is turned to 4 times I times 4, 4 times I. Okay, so here, just in case you forgot about I is equals to square root of a negative 1. That imaginary number unit. Okay, and then we have 2 solutions still. One is a negative, one is a positive. So let's see how we're going to reduce this. Okay, we're going to reduce this. To reduce this properly, we're going to, in the numerator, we're going to factor out the 2 on the top. Okay, 2 is factored out, so we have plus minus 2i. And as a result, the 2 on top and the 2 on the bottom, it will be reduced. So we ended up with negative 1 plus minus 2i. So we have, if we want to list 2 solutions, one is x1, which is equals to negative 1 minus 2i. And the other one is x sub 2, which is going to be negative 1 plus 2i. In fact, in this case, we have 2 complex number solutions. And these 2 complex numbers are also conjugates. Okay, they're conjugates. So in the case of b squared minus 4ac less than 0, so we have 2 complex number solutions. So we go back to the top. So instead of having real number solutions, now we have 2 complex number solutions. 2 complex number solutions in 1b squared minus 4ac. This is the 3 cases of quadratic solutions. Okay, equations with quadratic solutions. So these are the 3 cases using quadratic equation. And of course, the quadratic equations can be very different. In all these examples we have here, we have, A equals to a simple number, B equals to a pretty simple number, C equals simple number. But these 3 cases are all the cases you are going to encounter with quadratic solutions. Okay, so to summarize that to solve quadratic equations, okay, to solve the quadratic equations, okay, the solutions would be 3 cases. Okay, so here are the 3 cases. It's just a little bit smaller. Here are the 3 cases. Here are the 3 cases. Okay, thank you for watching. Keep on practicing.